here's an example of dependent events. All right, so I'm going to have the same type of example. I'm going to got my cards, shuffle them up, I pick a card. K1 is still going to be that the first card is a king. But here's the deal. On this experiment, I'm going to take that king, I'm going to put it down. Now, I got my first king. Now I'm going to pick another card. So I'm not replacing that king in my deck. I'm going to leave it out. So now the probability of a second king is different. Okay, so the probability that the first card is a king, K1, is still going to be, 4/52 or 0.0769. Okay, so if this card was a king that I picked out, and I look at my deck, I no longer have 52 cards in it. I have 52 minus 1 cards. I have 51 cards left. And if I got a king here, then there's only 3 kings. So now the number of kings over the number of cards is now 3 over 51. And this notation here, this is the probability of K2, probability that the second card is a king. And this little line here, this means given, all right? So given K1. So the probability the second card is a king, given the first card is a king, is 3 over 51. And we're going to talk about these types of probabilities in the next week, in the next section. All right. Now, let's say when I picked my first card, I shuffled, I picked a first card, it was not a king. All right. So I've got a card, let's say it's a queen. I got my queen, I put it down. Now, what's the probability of getting a king? Well, I still only have 51 cards left, but I have all 4 kings in there. So this one, the probability that my second card is a king, given that my first card is not a king, then this, I've still got all 4 kings over the 51 cards. All right. Now, both of these, 3 over 51 and 4 over 51, are different from 4 over 52. So knowing whether or not I have a king in the first card affects the probability of the second one. And so when I have things that, if I have an event that if it occurs affects the probability of another event, then that means they're dependent. So this is the definition of dependence. You can think about this as that the probability of the second event depends on the first event. So the second card depends on what happens in the first card. So they're dependent. All right, so let's look at some events and decide whether they're independent or dependent. All right, here is a couple of events. My first event, E, is that a person is male. All right, so we have a man here. The second one is that the person owns a pickup truck. Are these independent or not? All right, or independent or dependent, let's call it that. So my question is, does the second event depend on the first event? Does the probability? So did the proportion of people who own cars depend on whether they're a male or not? All right, so basically what I'm asking is the proportion of males who own pickup trucks different from the proportion of females who own pickup trucks? And the answer is yes. So the gender affects the probability of having a pickup truck. So this is dependent. Now you might think I'm wrong, but I would say I'm pretty confident. I've been wrong before, once or twice. I'm pretty confident that a larger proportion of males own pickup trucks than females. All right, next one. There's a person and they make at least $100,000. That's pretty good money. Second, a person has a bachelor's degree. So are these independent of each other? So whether a person has a bachelor's degree, are their incomes distributions the same? Is my probability distribution going to be the same for somebody without one or with one? And the answer is no, they're not the same. So when they're not the same, so the probability of making at least $100,000 depends on whether or not you have a bachelor's degree or not. So this is dependent. And in case you don't agree with me, I put a link on here that you can go look for yourself. So this is some data that somebody collected. or you can just trust me. But you know, maybe you shouldn't trust me, even on this one. You might, if you disagree with me, go look it up. Verify. All right. Now we got part C. Let's see. A random woman in Kentucky believes men are paid more than women for the same job. Okay. Let's ask a different random woman in Kentucky if she believes men are paid more than women for the same job. So let's say we know what this random woman thinks. She's like, the first woman is a yes. So let's say, yeah, so she believes, I asked a random person, and she believes that men are paid more for the same job. All right. Second woman, does that change the probability that the second woman feels that way? So does, you think about it, here's somebody that's in Lexington, does their opinion, if they say yes, is that going to affect my opinion about it? I'm going to tell you no. My opinion, I don't even know that person. These are random people. So their opinion is not going to affect my opinion. So these are independent. What happened to me? There we go. All right, let's look here. A person has a bachelor's degree and a person wears a size 9 shoe. All right, so let's say I know somebody has a bachelor's degree. Does that change the probability that they wear a size 9? No. So it does not affect, the first does not affect the second, and the second does not affect the first. So these are independent. All right, now this section, we're going to talk about the multiplication rules for independent events. Next section, next week, we'll talk about the multiplication rule when they're dependent. It's a little bit different.